students, I am Ekta. Euclid, one of the most important mathematicians, wrote an important book named Elements in 13 volumes. The first 6 volumes were devoted to geometry, and for this reason, Euclid is called the father of geometry. But in the next few volumes, he made fundamental contributions to understanding the properties of numbers. One among them is Euclid's division lemma. This is a simplified version of the long division process that you were performing for the division of numbers in earlier classes. Let us now discuss Euclid's lemma and its application through an algorithm termed Euclid's division algorithm. Learning outcomes. To study the concept of Euclid's division lemma. To understand Euclid's division algorithm. To find the LCM and HCF using Euclid's division algorithm. Keywords from this lesson: numbers, integers, quotient, divisor, remainder, Euclid's division algorithm, Euclid's division lemma, highest common factor, and greatest common divisor. Theorem 1. Euclid's division lemma. Let A and B, A greater than B, be any two positive integers, then their exit unique integers Q and R such that A is equal to BQ plus R, 0 less than or equal to R less than B. Note: the remainder is always less than the divisor. If R is equal to 0, then A is equal to BQ, so B divides A. Similarly, if B divides A, then A is equal to BQ. Example: we have 34 cakes. Each box can hold 5 cakes only. How many boxes do we need to pack and how many cakes are unpacked? Solution: we see that 6 boxes are required to pack 30 cakes with 4 cakes left over. This distribution of cakes can be understood as follows. The generalized form of Euclid's division lemma. If A and B are any two integers, then their exit unique integers Q and R such that A is equal to BQ plus R, where 0 less than or equal to modulus R less than modulus B. Let us see one example. Find the quotient and remainder when A is divided by B in the following cases. A is equal to minus 12, B is equal to 5. Solution. By Euclid's division lemma, A is equal to BQ plus R, where 0 less than or equal to R less than modulus B. Minus 12 is equal to 5 into minus 3 plus 3. Therefore, quotient Q is equal to minus 3, remainder R is equal to 3. Go. Example. Show that the square of an odd integer is of the form 4q plus 1 for some integer q. Go. Solution. Let x be any odd integer. Since any odd integer is one more than an even integer, we have x is equal to 2k plus 1 for some integer k. X square is equal to 2k plus 1 whole square. 4k square plus 4k plus 1 is equal to 4k into k plus 1 plus 1 is equal to 4q plus 1, where q is equal to k into k plus 1 is some integer. Euclid's division algorithm. In the previous section, we have studied Euclid's division lemma and its application. We now study the concept of Euclid's division algorithm. The word algorithm comes from the name of 9th century Persian mathematician Al-Khwarizmi. An algorithm means a series of methodical, step-by-step procedures of calculating successively the result of earlier steps till the desired answer is obtained. Euclid's division algorithm provides an easier way to compute the highest common factor of two given positive integers. Let us now prove the following theorem. Theorem 2. If A and B are positive integers such that A is equal to BQ plus R, then every common divisor of A and B is a common divisor of B and R and vice versa. Euclid's division algorithm. To find the highest common factor of two positive integers A and B where A greater than B. Step 1. Using Euclid's division lemma, A is equal to BQ plus R, 0 less than or equal to R less than B, where Q is the quotient, R is the remainder. If R is equal to 0, then B is the highest common factor of A and B. Step 2. Otherwise applying Euclid's division lemma, divide B by R to get B is equal to RQ1 plus R1, where 0 less than or equal to R1 less than R. Step 3. If R1 is equal to 0, then R is the highest common factor of A and B. Step 4. Otherwise using Euclid's division lemma, repeat the process until we get the remainder 0. In that case, the corresponding divisor is the HCF of A and B. Note, the above algorithm will always produce a remainder 0 at some stage. Hence, the algorithm should terminate. Euclid's division algorithm is a repeated application of division lemma until we get zero remainders. The highest common factor HCF of two positive numbers is denoted by A, B. The highest common factor HCF is also called as greatest common divisor GCD. Illustration 1. Using the above algorithm, let us find the HCF of two given positive integers. Let A is equal to 273 and B is equal to 119 be the two given positive integers such that A greater than B. We start dividing 273 by 119 using Euclid's division lemma, and we get 273 is equal to 119 into 2 plus 35, and that is equation number 1. The remainder is 35 not equal 0. Therefore, applying Euclid's division algorithm to the divisor 119 and remainder 35, we get 119 is equal to 35 into 3 plus 14, that is equation number 2. The remainder is 14 is not equal to 0. Applying Euclid's division algorithm to the divisor 35 and remainder 14, we get 35 is equal to 14 into 2 plus 7, that is equation number 3. The remainder is 7 is not equal to 0. Applying Euclid's division algorithm to the divisor 14 and remainder 7, we get 14 is equal to 7 into 2 plus 0, and that is equation number 4. The remainder at this stage is equal to 0. The divisor at this stage is equal to 7. Therefore, the highest common factor of 273, 119 is equal to 7. Example: find the greatest number that will divide 445 and 572, leaving remainders 4 and 5 respectively. Solution: since the remainders are 4 and 5 respectively, the required number is the HCF of the number 445 minus 4 is equal to 441, 572 minus 5 is equal to 567. Hence, we will determine the HCF of 441 and 567 using Euclid's division algorithm. Theorem 3. If A and B are two positive integers with A greater than B, then GCD of A and B is equal to GCD of A minus B, B. Highest common factor of three numbers. We can apply Euclid's division algorithm twice to find the highest common factor HCF of three positive integers using the following procedure. Let A, B and C be the given positive integers. Find HCF of A and B, call it as D. D is equal to A and B. Find the HCF of D and C. This will be the HCF of the three given numbers A, B, C. Example: find the HCF of 396, 504 and 636. Solution: to find the HCF of three given numbers, first we have to find the HCF of the first two numbers To find HCF of 396 and 504, using Euclid's division algorithm, we get 504 is equal to 396 into 1 plus 108. The remainder is 108 is not equal to 0. Again, applying Euclid's division algorithm, 396 is equal to 108 into 3 plus 72. The remainder is 72 is not equal to 0. Again, applying Euclid's division algorithm, 108 is equal to 72 into 1 plus 36. The remainder is 36 is not equal to 0. Again, applying Euclid's division algorithm, 72 is equal to 36 into 2 plus 0. Here, the remainder is 0. Therefore, HCF of 396, 504 is equal to 36. To find the HCF of 636 and 36. Using Euclid's division algorithm, we get 636 is equal to 36 into 17 plus 24. The remainder is 24 is not equal to 0. Again, applying Euclid's division algorithm, 36 is equal to 24 into 1 plus 12. The remainder is 12 is not equal to 0. Again, applying Euclid's division algorithm, 24 is equal to 12 into 2 plus 0. Here, the remainder is 0. Therefore, HCF of 636, 36 is equal to 12. Therefore, the highest common factor of 396, 504 and 636 is 12. Points to remember. Euclid's division lemma. If A and B are two positive integers, then there exist unique integers Q and R such that A is equal to BQ plus R, 0 less than or equal to R less than modulus B. If A and B are positive integers such that A is equal to BQ plus R, then every common divisor of A and B is a common divisor of B and R and vice versa. No. If A and B are two positive integers with A greater than B, then GCD of A and B is equal to GCD of A minus B and B. Thanks for watching. Like, share and subscribe.